Hey, Topping and Life's Math and History, and we're gonna be doing multiplying polynomials part 2. So in the previous video, we have been taking a look at how to distribute and multiply the simple polynomials, and we also looked at a more advanced polynomial, but sometimes those strategies aren't the only ones there. There are other strategies that we can use to multiply the polynomials. There's the area method, distribute, and FOIL. So today, we're going to review and learn about all of the three things and how it can get to our answer efficiently. So let's start with the area method. The area method is very, very visual because when you're working with polynomials, you usually see variables, numbers, and variables with exponents. And when we hear the word area, there's a formula that we hear almost all the time that uses an exponent and something that can be very helpful. It is the area, something we learned in geometry because the area of a square is length times width or length times height. So a square has equal sides and they are all equal. So we can say a more advanced formula for the area of a square is area equals x squared. As x here, x squared inside it. Number 2, if we insert something in for x's, if we say 10 times 10, that is going to be equal to 100. Or 10 squared also equals 100. So, with the area method, we're going to use a lot of multiplying visually on a square or a rectangle. Here's an example. So, we have length times the width, and that will equal a square. Or, if we go on to the top, x squared. So, here is the problem we'll be trying to solve today. This can also be known as a box method because we will be using a box. So we want to multiply x plus 10 and x plus 7. So what we're going to do is x plus 10 right here and x plus 7 right here because we're trying to make a box. So this is what our box is going to look like. So what we're going to do is x multiply that by x, that will become x squared. And we're going to color code that by here's red and here is going to be green. So red is going to cover it and green is also going to cover it. X multiply that by 7 will become 7x. So we're going to put brown near the 7, shade that in for 7, and put red in for it, and that will be known, and it will become 7x. X being multiplied by 10, we're going to shade green. We're going to shade green and shade in purple because 10 doesn't have a color yet. And when we do that, that will become 10x for this box right here. And last but not least, we have purple and we also have brown, which means 10 multiplied by 7 will become the usual 70. So from all the boxes, we have to add them all up. X squared plus 7x plus 10x plus 70. And when we do that, we have to combine like terms. X squared plus 17x plus 70. So that is going to be our new expression for this when we multiply the two. So the box strategy or the area method is definitely going to work. and is very helpful if you are a visual person. This can also relate to the area model, like 63, and if we write 16. So we make 4 boxes, and we write 6 times 1 is 6, or 60 times 10, 600. Then we do it just like this way. But with the area model, you probably learned that in elementary school. 18 and 30. When we add them all up, we get an answer of 1008. So that's the area model. It relates to this one. So we have learned the area method. Check. Let's distribute. So when we distributed in the last video, we have been seeing equations like 7v multiplied by 2v squared plus 3. But sometimes you'll have a much larger equation to handle. And what you gotta do is distribute this equation over multiply that to this equation. But when you have two giant equations, the distributive property is going to have a little bit different steps and a little bit more steps. Here's an example. We gotta do 5p squared multiplied by 2p squared, and also multiplied by negative p cubed, or negative 3p to the power of 3. We'll get a new answer, or a new expression right here, when we have 5p squared. So, when we do 5p squared multiplied by 2p squared, we're going to get 10p to the power of 4. Because when you multiply, you add the exponents. So 10p to the power of 4. Now, 5p to the power of 2 multiplied by negative 3p to the power of 3, we're going to get an answer of negative 15 to p to the power of 5. That is going to be our expression when we do 5p squared. Now, we have to do negative 3 multiplied by 2p squared, and negative 3 multiply that by negative 3p cubed. So for our next expression, we have negative 3 as our lead number. Negative 3 multiplied by 2p squared, that is going to equal negative 6p squared. And negative 3 multiply that by negative 3p cubed, we will be able to get positive, because negative times a negative is a positive, positive 9p cubed. And that is going to be our expression for our lead number, which is negative 3. The lead numbers are known as ones that you gotta multiply. After we do that, all we have to do is combine like terms, put it in standard form, and kaboom, we're done. But wait, we can't really put it in expanded form because they're different exponents. Even though they're the same numbers and the same variables, the exponents are different. So instead of combining like terms, we're just going to put it in standard form. Always put the biggest exponent first, then the second, third, fourth. So our answer is negative 15p to the power of 5. Add that by 10p to the power of 4. Add that again by 9p to the power of 3. Then subtract that by 6p to the power of 2. That is going to be our new expression. And that is how we multiply a distributive. We use a distributive property with the two equations. That is how we distribute. The last thing we're going to look at is FOIL. When you hear the word FOIL, you've probably been thinking a lot about like tin foil or the plastic shiny piece, but foil is actually related to the distributive property because it's almost the same thing. But FOIL is actually an acronym. FOIL represents first, outer, inner, and last. And it shows you what the steps are and what to multiply. So let's start multiplying. First, we have to do the first two numbers of the parentheses. We have 2x and 5x. Multiply them together to make 10x squared. Remember, multiplying by variables by itself will result in an exponent. So 10x squared. Check. We did our first. Now the outer numbers. That represents the numbers that are on the outer edge of the parentheses. So 2x and negative 8. When we do that, 2x multiplied by negative 8, we get negative 16x. The variable will overpower the equation and answer to make it a negative 16x. So that is our outer numbers. Check. Now we have to do the inner numbers. Those are the numbers that are squeezed in the outer numbers. So the inner numbers get a big hug from the outer ones. Multiply these two together. 5. Multiply that by 5x. When we do that, we get 25x. And last but not least, check. The last thing we gotta do is put the last two numbers of the parentheses, multiply them together. When we do 5 multiplied by negative 8, we get negative 40. So now, what we gotta do is combine all of them, combine like terms, put them in our standard form, and we'll be able to get our answer. Let's do it. So, we have 10x squared first, because that is an exponent. Exponents are boarding the plane first. Now, we have negative 16x and positive 25x. 25 minus that by 16 will get a positive 9x. Subtract that by 40 and bam! There is our answer! 10x squared plus 9x minus that by 40. When we multiply the equations or the expressions, 2x plus 5 multiplied by 5x minus 8. We are going to get 10x squared plus 9x minus that by 40. That is how we do the FOIL method. And that is the 3 ways we can multiply. I hope this video has helped you. Thank you for watching Taoping Online's Math Industry. Like and subscribe.